Okay, we're going to watch a little video about joining things together, putting assemblies together. And you've already done a little bit with the puzzle cube. You did a rigid one. There are others that we do, and we're going to follow along here with the video. So let's go ahead and watch it.
One of the most important aspects of working with assemblies is defining the correct motion between components. Fusion 360 makes it simple to define motion by using joints, which snap points together on two components and then open up certain degrees of freedom to achieve the right motion. There are 7 joint options to choose from, each one having different motion associated with mechanical connections. The first joint type is the rigid joint, which locks all degrees of freedom and keeps the two components fixed to one another. You can see this animation when I click the play button. The two components shake on screen to show that they're fixed to one another. The alignment options above set the relative position of the joint origins and are available for all joint types. The second joint type is the revolute joint, which has a single rotational degree of freedom, much like a hinge. When I select this option, an additional motion option, rotate, becomes available. This specifies the axis that the components will rotate about. As I change this option, notice that the preview of the motion changes. If I don't want the rotation around the standard X, Y, and Z axes, I can select an edge in the model to use as a custom axis to rotate about. The next joint type is the slider joint. As the name implies, this joint type is used for components to slide along one another, having a single translational degree of freedom. The options for the slider joint are similar to the revolute joint, except the axis that's selected allows the components to slide in that direction instead of rotating around the axis. The cylindrical joint type is the first joint to open up 2 degrees of freedom. Components joined with a cylindrical joint can translate and rotate around the same axis. Since the same axis is used for translation and rotation, only one axis option can be selected. If I animate the preview, you can see that the first selected component spins around the axis as it translates back and forth. The pin slot joint type also allows for 2 degrees of freedom, one translational and one rotational, but in this case, the axes can be different from one another. Because of this difference, 2 motion options are available, one to control the rotation and another for the translation, or slide. If I click the Animate button, notice that the first selected component translates, or slides, in one direction while rotating around a different axis. The planar joint type allows for the most degrees of freedom, 3. The planar joint allows for 2 directions of translation within a plane and a single rotational direction normal to that plane. It is designed for joining 2 components such that they can slide fully across them and rotate across that planar surface. A simple way of thinking about this is a hockey puck sliding across the ice. The puck can move in 2 directions on the ice, and it can rotate as it slides. To make working with planar joints easier, I recommend specifying the rotation axis first, and the sliding directions will automatically be set to the other 2 axes. The final type of joint type is the ball joint. This joint has 2 degrees of rotational freedom, pitch and yaw. These 2 terms may be a little unfamiliar, but all that you need to know here is that the pitch allows the components to rotate around the z-axis, while the yaw rotates the components around the x-axis. Choosing the right joint type is fairly intuitive, and it's always best to choose a joint type that only opens up the necessary degrees of freedom. This will keep the model from moving unexpectedly. Not only will this make the model more robust, but it will also reduce the computations needed when experimenting with the assembly, which will help speed up the design process. One of the most important
So there you
aspects of
go.
working with
You just went
assemblies
through it.
is defining the correct
Looks like
motion
starting
between
again.
components. Fusion 360.
Okay, so you need to load up Fusion 360, and I have the dimension drawings for you to make some of these, and then you go through the assembly tab and hit on joints, and then figure out which joint you want to do. Okay, so I'm going to bring up Fusion, and I've made these already. Let's get some of these error mistakes here. So here's a planar one. Okay, it looks like a hockey puck. There's the animate button. Okay, so I've already made a couple of these. So I will just go over here and let's see if we can find what some of them are. So let's go down a little ways. Once you've made each of the files, each of the designs there, you might want to call them like Revolute 1, Revolute 2, to be able to go through and find out what they are. So let's see. Here's Revolute 1 up here. So I'm going to double click on it to open that one up. There you see it. And then I'm going to click and drag Revolute 2 on top of it. Let it think for a little bit so it puts it right there together. I'm going to move it back a little ways. Okay. So we'll move it out of the way a little bit. Then go okay. Now to go through, I'm going to widen my picture here. Go to Assemble. Go to Joint. Okay. Select which one you want to do. So for kicks and giggles, let's do this one right here. And for the second one, let's do it right here. Okay. Now, what kind of motion did I have? Well, I didn't want a planar motion. I want to do a revolute. Okay. Looks pretty good, except they're on top of one another. So you may have to go through and do maybe this side with the back side of this one. Okay. But you still go through the same steps. Assemble, joint. Okay. Select the first one. So I'm going to move it around a little bit. Okay. And I'm going to click back on the home. And I want component 2. Before I do that, I'm going to change the motion to revolute. So it revolves around. And I'm going to come back up to position. And click on this part right here. And you can see that it rotates around in that respect there. If you want to see the animation, you have to click on the motion and then click on animation. Now, I'd also like to have you, and it keeps going until you hit the animation or button again. Also, play with the angle and play with the offset. Okay, so we're going to look at maybe an offset on the Y. Okay, maybe we want to type that as a 1. So we're 1 inch off. Well, that's the wrong one. Okay, we'll change that back to 0. Let's try the X one and make it offset of 1. Okay. No, that's not quite right either. So you play around with these and see what you can do and have fun with it. Okay? Good luck in doing this, and we'll see you again. If you have any questions, ask me in class.